One way to make acidic buffer, a buffer that has pH less than 7, is by adding a weak acid, such as ethanoic acid, to its own salt, such as sodium ethanoate. And the question is, why do I need salt in this buffer? What is the role of the salt? If you take your weak acid, ethanoic acid, there is partial dissociation. So this acid is going to stay as 95 to 99% as a molecule, and only the remainder, like 5%, is going to break apart to give you the conjugate base. It is a conjugate base, ethanoate CH3COO-, and it's a good base, but if you have a small quantity, you cannot have the buffer. So the acid is good, the conjugate base is a small quantity. Now if you add some salt to it, salts are going, if they are soluble, they are going to break apart and dissociate 100%. The role of the salt is to provide the conjugate base in a larger quantity. Then you have, by adding the salt to your acid, you have both components in exaggerated amount and you can have a buffer. So now to this buffer, if you add an acid, for example HCl, the HCl is going to react with the conjugate base. So the conjugate base is going to neutralize this added acid HCl, which the H plus is the role that, and it's going to neutralize it and give you some CH3COOH back, and its pH is not going to fluctuate by much. Now what happens if you add a base to this buffer, NaOH? Then again, from NaOH, only OH minus is the species that is going to play any role, and the OH minus is going to be neutralized by your ethanoic acid, CH3COOH, plus the sodium hydroxide, or the hydroxide of the sodium hydroxide will give you CH3COO-, ethanoate, and H2O, and your pH is not going to fluctuate by much. So in order to make acidic buffer, you need weak acid and its salt. The role of the salt is to provide a larger quantity of the conjugate base. So this is acidic buffer, a buffer that has pH less than 7, and that's how you make it. This is one way to make that buffer.